Good morning, everyone. We're group number 2. Today we're going to be talking about how to solve a flow over cylinder. So first off, we'll select our analysis system, fluent, and then we'll select geometry, new design modeler. From here, we'll select the XY plane and then select sketch from the toolbar. We'll check for units. Select sketching from the bottom left tab. And we'll select a circle. We'll draw two circles, one of them being the cylinder and one is the enclosure circle. Then we'll select dimensions. We'll select general. From the bottom left tab, we can modify the dimensions we have. The first circle, the cylinder will be 1 meter, and the enclosure circle will be 64 meters. We'll then select concepts from surfaces, from sketches, and we'll select the sketch and apply and generate. To create the inlet and outlet, we will split the surface by drawing a line to split the surface. We will trim the axis line and trim the lines inside the circle that's inside the cylinder. We will select concept lines from sketches, then select the two lines. Apply then generate. Then we will go to tool to project the line on the surface. Type edges on body and target the surface. Generate. Now we can see that the surface is split. We can suppress the lines. And now we can change surface body from solid to fluid. Now geometry is done. Moving on to my colleague who's going to be explaining how to do the mesh setup. Thank you.
Thank you, Muhammad. And now let's start with the mesh. So first we will generate default mesh. As you can see, the mesh is not structured. So we'll go to mesh, right click, insert, and then face meshing. We will select the two surfaces, apply the geometry, and then generate. Now we have structured mesh. However, the element size is too big, so we will go to mesh, right click, insert, and then sizing. We will select the edges of the surrounding and the edges of the cylinder. We will apply the geometry, and then we will change the type from element size to number of divisions. We will choose a 96 number of divisions, and we will change the behavior from soft to hard. Then generate. We will also do sizing for the partnering line. So again, we will add sizing, choose the two lines, apply to geometry, then change the type to number of divisions, choose 96 number of divisions, change the behavior from soft to hard, and we will also add bias. We need the dense part of the bias to be near the cylinder. So for the bottom part, we will add reverse bias. And now generate. Now we need to create name selection for each part. So for the left part, we will click on it, the left edge, and then we'll right click and then create name selection. We will call it inlet. For the right edge, we'll call it outlet. And for the cylinder, we will select both edges and call them cylinder. So now we'll go to workbench and then update the mesh. And now I'll leave you with my colleague Yaro to discuss the setup.
Thank you, Anas. Now we will start with the setup. So from this window, we will choose the double precision, and for the solver processes, we will choose number 2 because we have 2 logical processors in the laptop. Now from the models, we will go to the viscous and change it to laminar. And then from the monitors, we will go to the report plots, press new, and then again new, and then force report, and finally drag. We will put the report file and the report plot. Print to console, and then press OK. We will also change the material properties. We will go to the fluid and select air. The density will be changed to 1 and the viscosity to 0.05. Then we will go to the cell zone conditions to make sure that the surface body is fluid. The material for surface is air, so we then just click apply. Then we will go to the boundary conditions for the cylinder and ensure that the type is wall. We made sure that the wall motion should be stationary wall and the shear conditions is no slip. We will choose the inlet and make sure that the type is velocity inlet. So double click on the inlet and the velocity inlet pops up. We will change the velocity magnitude from 0 to 1 meter per second to have Reynolds number of 20. Then we will proceed to the outlet and ensure that the type is pressure outlet. Then from the monitor, we will choose residual and we will change the absolute criteria from 0.001 to 1 multiplied by 10 to the power of minus 6. Now we will start the initialization and choose hybrid initialization and click initialize. We will run the calculations. We will finally run the calculations, and for the number of iterations, we will choose it as 2000 and click calculate. Now I will leave you with Anas to discuss the results.
Thank you, Yara. And now for the results. First, we will plot the pressure contour. So we'll choose a contour, we'll call it pressure. We will select the location at the symmetry, and then we will apply. This is our pressure contour. Similarly, we will add a velocity contour. It will be at the symmetry, however the variable will be the velocity. Now we will add the streamlines. To add the streamlines, we need to create a line for the streamlines to start from. So we'll call it seed line. And now we will apply. We will choose the samples to be 50. And now we will create streamline. To start from seed line 1, and we will have 50 points. This is our streamline. We will create another streamline for the wake region. So similarly, we need to create another line for the wake region. We'll call it seed line 2. And it will be exactly to the right of the cylinder. Now we will apply, and we will create our second streamline. The direction will be forward and backward, and we will hit apply. This is the streamline for the wake region. However, it's too dense, so we'll decrease the number of points. Now we will create a plot for the pressure versus the angle. However, we need to make an expression for our angle. So we'll go to expressions, new, we'll call it theta expression. And from definition, we'll right click, functions, CL, and we will add cosine inverse. For our variables, we will add variables, other, then we'll go to geometric and add x. It will be divided by r. Our radius is 0.5 meters. We will hit apply, then we will go to variables and we will add our theta variable. Now we will link our theta expression with the expression that we made. And then we will click apply. Now we need to make a plot. We will call it pressure plot. But before we make the plot, we need to make a polyline around the cylinder. We'll call it cylinder, and then we'll choose the method, boundary intersection. Boundary list, it will be the cylinder, and the intersection width, it will be the symmetry. We'll click apply. Then we will create our plot. It will be pressure versus theta. And the location will be the cylinder. For the x-axis, we will choose theta. And this will be inverted axis. For the y, it will be pressure. And we will hit apply. This is the pressure versus the angle plot. As you can see, at the stagnation point, we have the highest pressure. Then the pressure keep decreasing as the velocity keep increasing. Thank you for watching.